Namaste to all of you. In today's video lecture, we would like to discuss about the determination of hardness of water in laboratory. So the hardness, which is a tendency of a water, and it is defined as the presence of chloride, sulfates, carbonates and bicarbonate salts of calcium and magnesium ion, basically is a particular property. It is a tendency, and this hardness, the amount of hardness, can be determined by taking a particular method which is called as the volumetric analysis. Volumetric analysis. And this volumetric analysis is carried out by titration. Here, the titration method which is adopted for this particular determination is called as complexometric EDTA titration. This titration is referred as the complexometric EDTA titration because of the formation of a particular complex, and this complex is actually formed by calcium or magnesium ions. So the formation of a particular type of complex brings a color change. Of indicator, color change of indicator, and we get a endpoint. So the endpoint comes due to the formation of a certain complex, and this complex is formed by the calcium or magnesium ions present in a water sample, and the indicator actually play a significant role here, which bring a information about an information that the endpoint comes, and the endpoint here is coming from the formation of this particular calcium or magnesium ions complex. That is why this particular titration is called as complexometric EDTA titration. Now we would like to discuss about the particular requirements, the chemical requirement for the practical. So we needed certain chemical solutions. For example, number one, SHW. SHW means standard hard water. Standard hard water is a water sample whose strength or concentration or hardness in this particular case is known to us. It is known. It is known to us. It is given here. It is already given here. And suppose 1 gram per liter, the strength. And this standard hard water is prepared by mixing a calcium carbonate in the distilled water. Second requirement is UHW. UHW means unknown water, unknown hard water. This particular water sample is taken to determine the hardness. It is a water sample, unknown water sample, and whose hardness is to be determined. The third one is called as the EDTA solution. EDTA solution, the third chemical requirement is EDTA solution. EDTA, the full form of EDTA is ethylene diamine tetra acetic acid. But generally this EDTA, ethylene diamine tetraacetic acid, is partially or sparingly soluble in water. So the solution, it is difficult to make a solution of EDTA because this EDTA salt is sparingly soluble, partially soluble in water. So to overcome this particular problem, we generally use a disodium salt of EDTA. The fourth requirement is buffer solution. We use ammonia buffer for this practical. It is the combination of ammonium chloride powder with ammonium hydroxide solution, and this EDTA solution is required to maintain the pH of the experiment, the pH of the solution, and here 8 to 11 pH is required to carry out this particular practical. This pH is needed because in the absence of this pH, the particular indicator doesn't work. Number fifth chemical requirement is indicator. Here we use a specific indicator called iriochrome black tea. This iriochrome black tea indicator is a pigment indicator, and this indicator originally looks like a black tea. This indicator shows a specific color range which is wine red to sky blue. In the alkaline medium, it shows the wine red color, and in the acidic medium actually it shows the sky blue color. When we add this particular EDTA solution from the burette, when we add this EDTA solution from the burette, actually acid is introduced in a conical flask, and which makes the medium, which turns the medium from the alkaline to acidic medium. Now, after discussing the chemical requirement, we would like to discuss about the procedure of the particular experiment. So the next step is procedure. Procedure of the experiment. So the procedure is, we take 10 ml of standard hard water in a conical flask. Then we also add here 2 to 5 ml of buffer solution. And we simultaneously add 1 to 2 drops of iriochrome black tea indicator, which is abbreviated as EBT. So after adding the EBT, we get here a wine red color. The solution turns in a wine red appearance. Now, when the wine red color comes, we add the EDTA solution, of course the disodium salt solution, EDTA solution from the burette. This solution can be added in a certain amount, ml by ml, or whatever you decide. We can add drop by drop a certain amount of EDTA solution, and we shake the conical flask and we check the endpoint. When the endpoint comes, the wine red color changes to sky blue color. Wine red color changes to sky blue color. So when the sky blue color comes, we have a certain volume. Suppose this is a burette and this is the 0.0 ml, the mark of 0.0 ml, and up to this point, suppose here the 10.8 ml, we are supposing this value here at 10.8 ml, the endpoint is coming, so 10.8 ml is the first endpoint. Or the particularly it can be shows as V2 ml. This V2 ml is for standard hard water, because we have started the procedure or the practical from the standard hard water first. After getting this first endpoint with standard hard water, we repeat this whole process to get the concordant reading. That means to get continuously, consecutively same reading, 10.8, 10.8. So when the second reading, when the second reading is also 10.8, there is a confirmation that the first reading is correct. After that, we apply this whole process with the unknown hard water sample, 10 ml of unknown hard water sample, of course in a conical flask, plus 2 to 5 ml of buffer solution, and 1 to 2 drops of idiochrome black tea indicator, and we repeat the same process as we have repeated earlier. So with the unknown hard water, we get the second endpoint. Suppose the second endpoint is coming 5.5 ml. So this would be the endpoint, and we have to confirm this 5.5 ml reading once again in a second step, and if we get consecutively the same reading 5.5 ml again, so we get here the second endpoint, which is called the endpoint for for unknown hard water, V2 ml. We get the second V2 ml, we get the second reading with the unknown hard water. So this is the procedure. We particularly in this experiment, we titrate the two solutions, standard hard water and unknown hard water. So it is called as the double step titration. double step titration. Here the EDTA solution remains same and which is filled in burette. This EDTA solution remains same and it is filled in a burette. Okay, so this is the procedure. Now after discussing the procedure, the third step is calculation. Calculation can be done by using a formula N1V1 is equals to N2V2 is equals to N3V3. This formula here, the terms N1V1 or N2V2 or N3V3 has their simply meanings. N means normality, V means volume. This N1V1 is for standard hard water. This N2V2 is for EDTA. This N3V3 is unknown hard water. And we apply this formula in two parts. Number A, for calculation of N2. To calculate N2, we use N1 V1 is equals to N2V2. So here N2V2 is for standard hard water. Here this standard hard water. In the second step, we use the remaining part of the formula, which is for getting N3, and the formula is N2V2 is equals to N3V3. Here this N2V2 is again giving the values of EDTA, but this time EDTA is used for this unknown hard water. So here this V2 is for unknown hard water and here this V2 is for standard hard water. In the third step, we get the hardness is equals to equivalent weight multiplied by normality. So equivalent weight in terms of calcium carbonate, because we always calculate the hardness in terms of calcium carbonate equivalent. So it is 50 multiplied by N3. So you get the answer here in gram per liter. To convert is into the particularly ppm or milligram per liter, also calculate here, multiply here, 1000. So we get here the answer in ppm or milligram per liter. So this is all about the determination of hardness of water in laboratory. It is done by a particular titration which is called as complexometric EDTA titration. In my another video lecture, I have discussed about the chemical reactions involved in this particular titration. So you can you may go for that particular type of video lecture, and I hope the concept regarding this particular topic may be cleared for your this is the particular titration, and the observation table for this particular particle is very simple. So I am not discussing here the observation table. And this is all about the determination of hardness of water in laboratory. Thank you very much. And please subscribe my channel, press the bell icon, and don't forget to like and share the video. Thank you.